Okay, today we are going to start lesson 2 in unit 1, okay, which is about relation and mapping of the functions, okay?
Okay.
Okay, great. So first I will start with a question or one simple example like this, okay? If x equals the set of 2 and 5 and y equals the set of 1 and 4 and 7 and r is the relation, okay, from x to y, a relation b, which is ARB, a relation b means a smaller than b, okay? State the relation. Now state the relation and represented by arrow diagram and the Cartesian diagram. Okay, so the relation now here, it's mentioned in the question that a relation b means a less than b, okay? So now the
Okay.
relation will equal the set of first a less than b, so this means 2 less than 1, no, of course no, okay? So 2 is less than 4, yes, so 2 and 4, and then 2 and 7, of course 2 is less than 7, right? So 2
Right.
and 7. Okay, then the second element, 5. 5 is less than 1? No. 5 is less than 4? No. 5 is less than 7? Yes. So 5 and 7. And 5 and 7. So this is the relation. Okay, now how to represent it using arrow diagram? Of course, we said that this one will be A, right? The set of elements of X is A, and the set of elements of Y is B.
B.
Okay, great. Then how to represent it using arrow diagram? It's very easy. This one will be X, and this one will be Y. What are the elements on inside X? It's 2 and 5. What are the elements inside Y? It's 1 and 4 and 7. Now use the relation, okay, to draw your arrows. First, ordered pair is 2 and 4. So one arrow from 2 to 4. Next, 2 and 7. So one arrow from 2 to 7. And then finally 5 and 7. So one more arrow from 5 to 7. That's it. Okay?
Okay.
Okay, so this is the representation of the relation using arrow diagram. Then what about the Cartesian diagram? It will be the same as we studied before. Okay, I'm going to draw the Cartesian diagram, which is like this. Cartesian diagram will be one rectangle like this one, okay, and one like this one. So this one, which is horizontally, represents X, and this one represents Y. Now, what are the elements inside X? Actually, it's 2 and 5. And inside Y, 1 and 4 and 7. Then draw the perpendicular net, which is horizontal lines from 1 and 4 and 7, and then vertical lines from 2 and 5, like this. Now, represent your points. The first point is 2 and 4. Where is 2 and 4? 2 on X, 4 on Y. So this means this point. And then 2 and 7. So it will be this point. Then 5 and 7, it will be this point on the top. Okay?
I do this if this question is to me in the exam. I will draw it in the paragraph.
Yes, you will draw it like this, okay? Using the perpendicular net, and then
Paragraph.
the represent the points, okay? On the perpendicular net, 2 and 4, 2 and 7, 5 and 7, okay? And you can also write down
In the paragraph.
Sorry?
In the paragraph.
You mean on the graph paper? No need,
Yeah.
no need to draw it on a graph paper, on normal paper, okay? Because there are no dimensions
Okay.
here or measurement, okay? Also, you can place the points or no, yani no problem, we don't care. If this point is 2 and 4, so we may write 2 and 4 like this, beside the point. This one 5 and 7, so 5 and 7 like this. This one 2 and 7, so this point 2 and 7, and so on, okay? Now this one is clear?
Yes, clear.
Okay, great. So let's solve one more example related to this one. If x will equal
Sorry, 1
1.
minute. Sorry, 1 minute. Because my dad is
Oh,
calling me.
okay, no problem, Abdurrahman. Okay,
Oh,
okay. Now in this example, if x will equal the set of 1 and 2 and 3, 1 and 2 and 3, and y equals the set of 3 and 4 and 5 and 6. Okay. And R is the relation from X to Y. R is the relation from X to Y. Okay. Where ARB or A relation B means A plus B equal 6. Okay. Now state the set of R or state the relation. State the relation. Okay. So how to get the relation? So now relation will equal the set of. Now in this question, a plus b equals 6. So we said that this is this elements are a and this are b, right? So
right.
now the first element on x is 1. So 1 and we want that a plus b equals 6. So 1 and 5, right? So 1a plus b equals 6. 1 plus 5 equals 6. Then again 2 and of course 4, and then 3 and 3. That's it. Okay?
Okay.
Okay, so this is the relation represented by arrow diagram. Okay, it's very easy like before. And this one will be x, and this one will be y. What are the elements of x? Actually, it's 1 and 2 and 3. What are the elements of y? Only 3 and 4 and 5 and 6. Now represent the relation. 1 and 5 is the first pair, so one arrow from 1 to 5. Then 2 and 4, one arrow from 2 to 4. Then 3 and 3, one arrow from 3 to 3. That's it. This is using the arrow diagram. Okay, is it clear?
Yes, clear.
Okay, very good. Then let's solve one more example. Okay,
Okay.
if x equals the set of -2 and -1 and 0 and 1 and 2. Okay, and R is a relation on X. R is a relation on X. So this means X to X like this. Okay,
Yeah, export.
then the relation here, A relation B, means A is the additive inverse of B. A is additive inverse of B. Okay, then state the relation and represented by arrow diagram, Cartesian diagram like this. Okay, so additive inverse means the additive inverse of the number means the same number. If it's 2, so the additive inverse will be the same number, but with different sign. So +2, it will be -2. If it's a -3, so the additive inverse will be +3. Okay?
Okay.
So it will be the same number, just I'm changing the sign of the number. So if it's 1/3, so the same number 1/3, but it changes the sign, so -1/3. Okay, so simply now The relation on X means X to X. Okay, so we will consider that there is another set which is X, and the relation is from X to X. Okay, so now the relation will equal the set of the first term is -2. So the additive inverse will be 2. Okay, so -2 and 2. Then -1. What will be the additive inverse? So it will be 1. So do we have 1 here? Yes, 1. Okay. And then the next term is 0. Actually, the additive inverse of 0 is 0. Okay. So 0 and 0. Then the next element is 1. So 1 and -1. And then the last element here will be 2. Okay, which is 2. So 2 and -2. So this is the relation. Okay, if we want to represent it using arrow diagram or Cartesian diagram, it will be very easy. Okay, so let's clear this area on the board. We'll clear this small space so that we can draw the arrow diagram. Okay, so now it's only a relation on X so that we can represent it using 2 ways. The first one using these 2 rectangles and place the elements, okay, and then arrows. Okay, so what will be the second method? Actually, I will represent the elements like this. This one is -2, then -1, then 0, then 1, then 2. Any shape. So this is -2, -1, 0, 1, and 2. Okay, so now represent it using arrows, -2 and 2. So -2 and 2. One arrow from -2 to the element +2, like this. Then -1 and 1. One arrow from -1 to 1, like this. Okay, then 0 and 0. We said that before. If it's the same element, 0 and 0, so it will be like a circle, okay, or a loop like this on the number with one arrow like this. Okay, then 1 and the -1. Now 1 and -1. So one arrow from 1 to -1, like this. Okay.
Okay.
And then the last one, 2 and -2. So one arrow from 2 to the element -2, like this. Okay? Are we clear?
Yeah, it's clear. But this question, what is the name of this question?
The name, the title, okay, of the question now, fx equals, and then there is a given set.
Not the last one, the last one.
Okay, it's the arrow diagram. This one, arrow diagram. Also,
Diagram.
yes, arrow diagram, but we use this method if it's only on one set.
Yeah.
Okay?
Okay.
If it's x on x, y on y, I mean that the set on itself. Okay?
No, I know it, but I forget the name.
Okay, great. Okay, the next one. The next question. If the opposite arrow diagram represents the relation R on X, so there is some elements like A, B, C, D, E, like this. This element is B. This one here, it's B. And then there is one here, which is C. And then there is one here, which is D. And then one here, A. And then here, E. Okay, now it's given in the question, the arrow diagram. It's like this one. There is one loop here, like this. And then one arrow from B to C, like this. And one arrow from A to C, like this. And then one loop here on D. And then from A to D, and from D to A, from A to D, and from D to A. And then finally, one from E to A, like this. Okay. In this figure, we want to get the relation. Okay, find the relation R, which is on X. So it's very easy to get it. The relation will equal. I have to check the arrows, right? So the first arrow here, it's B and B, right? This one I mean, B and B. So first B and B. Then the next, it's B and C. Okay, the direction of the arrow is very important, okay, because it shows us which one we will start with. So here, the direction from B to C. So this one, B and C. Then one arrow from A to C, so A and C. Then one arrow from D
A
to
and
A,
B.
so D and A. The other one from A to D, so A and D. Then there is one loop here at D, so this means D and D, right?
Right.
Then finally from E to A, so the last one, E and A. Okay, are we clear?
Yes, sir.
So this will be the relation. Okay, very good. Then the next point, okay, the next point in this lesson, it's about functions or mapping. Okay, functions or mapping. Okay, so let's give one example first and check what's the meaning of functions or mapping like this. If x equals the set of 0 and 1 and 2 and 3, and y equals the set of 0 and 1 and 2 and 3 and 4 and also 5 and 6. Okay, the relation here is from x to y. Okay, and ARB or A relation B means A equals 1 over 2B or equals half B. Okay, now write the relation. It's very easy. Okay, so now I'm going to write the relation will equal the set of, what is the first element here? Actually, it's 0. Okay, then A equals half B. So 0 and 0. Then 1. 1
1.5.
equal half. 1 equal half 2. So 1 and 2, right? 1 and 2. A equal half B. So if A equal 1, so B will equal 2. Okay, then 2. Element 2. 2 is half 4. Do we have 4 in
4.
Y? Yes, so 2 and 4. Then the last one is 3. 3 is half 6. So 3 and 6. Now we finished. Okay, so if we want to represent this one using arrow diagram, okay, or Cartesian diagram, first arrow diagram will be like this. So this one will be X and this one will be Y, right? So what are the elements inside X? It's 1 and 0 and 1 and 2 and 3. What are the elements of Y? It's 0 and 1 and 2 and 3 and 4 and 5 and 6. Okay, then represent your relation. First element or first ordered pair is 0 and 0. So one arrow from 0 to 0 like this. Then 1 and 2. One arrow from 1 to 2. Then 2 and 4. One arrow from 2 to 4. Then last one, 3 and 6. One arrow from 3 to 6. So this one is the arrow diagram. Okay?
Okay.
Okay. Now, we have to check if this one is a function or not. What's the meaning of the function? Now, all elements on X, okay, all elements on X, which is 0 and 1 and 2 and 3, has only image on Y, right? So it's a 0 and
Right.
0, 1 and 2, 2 and 4, 3 and 5. So all elements on X participated in the relation, right? And only participated once. There are no more than one arrow from each element, okay? So this
Okay.
means each element of the set X has been connected with only one element of the elements of the set Y, right?
Right.
Such that this relation is called a function, okay? Such that is called a function. So function means all elements on X have to participate in the relation once. So only X will participate once. So all the elements like 0 will participate one time, 1 will participate one time, 2 will participate one time, 3 will also participate one time. So in this case, it's a function. Okay, if in case there are two arrows from one of these elements on X, so this means this element participated in the relation two times. So this means it's not a function, right? I mean, if
Right.
we will add one arrow like this, so in this case, it's not a function, okay? Because 3 participated two times or has two images on Y. So in this case, it's not a function, okay? If I will remove one arrow from 3 like this, so now 3 didn't participate in the relation. So this means also it's not a function. So the conditions for the function, all elements on X have to participate only one time or have to share in the relation only for one time, okay, on Y. Okay, now it's clear?
Clear. Yeah.
Okay, so this one X related to the function, this X is the domain of the function. Okay, its name is domain. Then what about Y? Y, it's the codomain.
Coordinate.
Yes. Then the images, okay, or the elements, okay,
Okay.
which now are images on from X on Y, like 0, I mean this elements, I will show you, I mean 0 and 2 and 4 and 6. These 4 elements, okay, are the range, okay? So X is the domain, Y, all elements of Y is the codomain, and the images on from X on Y, these elements like 0 and 2 and 4 and 6 is the range of the function. Okay? Again, so the relation from X to Y is said to be a function in case if each element of the set X appears only once as the first element or the first projection in the ordered pairs of the relation. So here on the ordered pairs, 0, okay, and 1 and 2 and 3, these are the elements of X. So here first one is 0. Yes, 0 appeared here one time. 1, yes, 1. 2, yes, 2. 3. So all elements appears as a first projection in the ordered pairs. Okay? Okay, great. In arrow diagram like this arrow diagram, only one arrow, okay? Only one arrow, okay? Going
Okay.
out from this element to one element on Y, okay? Great. If it's like Cartesian diagram, if it's a Cartesian diagram, so let me clear the board to check also in case if it's on Cartesian diagram, how do we know that it's a function or not? Okay, we will draw the Cartesian diagram for this question. and the check. Just 1 second, I'm clearing the board. Okay, so now for Cartesian diagram, we said that this one will be X and this one will be Y, like this. So what are the elements on X? We said that, just 1 second, I will get it again. It was 0, 1, 2, 3, 0, 1, 2, 3. And Y, it's 0 and 1 and 2 and 3 and 4 and 5 and 6. Okay, now draw the perpendicular net, which is horizontal lines from these elements of Y and vertical lines from the elements of X, like this. Then represent the points. The first point is 0 and 0, like this. Then 1 and 2, 1 and 2 here. Okay, then 2 and 4, so 2 and 4 here. Okay, we missed one line from number or element 6, like this. Yes. Then last point, it's a 3 and 6. So at point 3 and 6, so it will be this one. I mean this point. Just 1 second. This point is 3 and 6. Okay?
Okay.
Okay. In the Cartesian diagram, okay, each vertical line here, okay, I mean vertical line, I mean these lines which are vertical, right? This one and this one, which are in green, and this one and this one. So each vertical line has one and only one point lying on this point. Okay, so this means this one is a function because 0 shared or appeared one time only. Okay, it was 0 and 0. 1 also one time. 2 also one time only. 3 also one time. So this means this is a function. Okay, in case if there is one more point, for example here. Sorry, I deleted by mistake. I mean one point here. Okay, so this means the 3 appears 2 times. So 3 and 1 and the 3 and 6. In this case, it's not a function. If there are no points at all, it fits like this, and there are no points at one of the elements like this. Okay, so the vertical line, 1 second. I mean the vertical line, this vertical line from 0 has no points at all. So this means 0, okay? This point at 0 didn't participated in the function or on the relation at all. So in this case, it's not a function. Okay? Are we clear?
Yes, clear.
Okay, so let's check one question to understand this point well. If X equals the set of 1 and 2 and the 3 and 4, 1 and 2 and 3 and 4. Okay, and Y equals the set of 1 and 3 and 5 and 7. So there are some relations are given, like relation 1, which equals the set of 2 and 3 and 1 and 1 and 3 and 5, and also 3 and 7, and then 4 and 3. Okay. Relation 2 equals the set of 1 and 7, 1 and 7, and 2 and 5, and then 4 and 1. Then one more relation, like relation 3. All these relations are given, okay? Then we have to check if these relations are functions or not. So the relation 3, it's 2 and 3. and 3 and 3, and then 1 and 5, and then finally 4 and 7. Okay. Now check that if these relations are functions or not. Okay, so the first relation, we have to check the elements of x. It's 1 and 2 and 3 and 4. So check here the first projection. 2, 1, 3, 4. Okay, but here 3 again. 3 is repeated twice as a first projection. So this means not function, right?
Yeah.
So the first relation, it's not a function. Okay, second relation, 1, 2, 4. So here x is 1, 2, 3, 4. So 3, okay, 3 didn't appear, okay, at the first projection. So this means also not function, right?
Right.
The third relation, 2, 3, 1, 4. Okay, so all elements on X, which is 1, 2, 3, 4, are represented here and shared on the relation. So in this case, this one is a function. So the first two are not functions, and the last one is a function. Okay, are we clear?
Yeah, it's clear. 3 and 5. 3 and 1.
Which one, Abdurrahman, you mean?
Number 1.
First function, okay, yes,
Yes.
first function 3 repeated twice here and here, right?
Yo,
3
because this
appears,
is not function.
3 appears 2 times, so this is not function. Here, 3 didn't appear at all, so also not function. But here on the last one, all elements appears as a first projection as one time only. 1, 2 here, one time, 3, 1, 4. All elements participates on the relation for one time. So in this case, this one is a function. Okay?
Okay.
Okay, so now we got it from the sets like X and Y and so on and the relations. Okay, so if we will get only the set and arrow diagram like this, let's check this type of questions. If X will equals 3 and 5 and 7 and 9. Okay, 3, 5, 7, 9. Great. The relation here is X to X, from X to X, or the relation on X, to the same meaning. Okay, and given some arrow diagrams like this one, this element is 3, and this element is 9, and this element is 7, and this one is 5, like this. Then this point 9, this point 7, and this point is 5. Okay, then from 3 there was a loop like this, and then 9 to 7, one arrow from 9 to 7, one arrow from 7 to 9, and then one arrow from 5 to 7. Okay, now check all the elements on this arrow diagram. There is 3, 5, 7, 9. Okay, check 3. It's the 3 and the 3. Okay, then 5, 5 and 7, one arrow from 5 to 7. Okay, great, one arrow from 5. Then one arrow from 7 to 9. Okay, and then one arrow from 9 to 7. Okay, so this one is a function. Of course, this one is a function because all elements, which is 3 and 5 and 7 and 9, participated once. This one is 3 and 3. This one is 5 and 7. This one is 9 and 7. And this one is 7 and 9, right? So
Yeah,
this
right.
means all elements participated on the relation. Here, 3, one time, 5, 7, 9. Okay, so in this case, this one is a function. Okay, are we clear?
Yeah, it's clear.
Okay, great. So this one is a function. We want to get the range. The range will equal, we said that it's the images on Y. So the range will be the second projection of the ordered pairs. Like what? Like first here, 7, 3,
3 and
9,
9.
and 7, but we will never repeat elements, okay, on the range. So the range only 3 and 7 and 9, and don't repeat 7. 7 here mentioned twice, just we will write it one time. So the range will be 3 and 7 and 9. We will not repeat elements,
And the
okay?
5.
5, you mean which 5? You mean this one?
Yeah, this.
No, the range, we said that it's the second projection of the ordered pair. So range only 7, second element, 7, 3, 7, 9. So these are the elements which are the images of X on Y. So here only 7 and 3 and 7 and 9, but we said that we will never repeat one element, so that we will write down only 7 and 3 and 9, not to
Okay.
repeat 7. Okay?
Okay.
Okay, so let's check one more. If it's also X will equal the same, like 3 and 5 and 7 and 9. And given the arrow diagram, this one is 3 and this one is 9, 3 and 9, like this. And then this one is 7 and this one 5. Okay, now the arrows, one arrow from 3 to 9, one arrow from 9 to 3, one arrow from 3 to 7, and then one arrow from 5 to 7. Okay, look at all elements. Okay, now from the beginning, we said that only one arrow from each element. Okay, check this one which is coming from 3 and this one which is coming from 3. So this means 3 participated twice as a first projection. Yes, because if I will check now here, this one 3 and 9 on the top, right? 3 and 9. This one 3 and 7, right?
Right.
So 3 participated twice in the relation. So this one is not function.
Not.
Okay?
Okay.
Okay,
If
very
it's
good.
repeated, it's not function.
If it's not repeated, okay, we have to check if it's a function or not. Okay, check element 7. Here, do we have one arrow going outside 7 to any other element? No. Okay, so this
Okay.
means also it's not a function because 7 didn't participate in the relation. What are the elements or the ordered pairs here? Let's write down the ordered pairs here. First here, 3 and 9, right? Then
Yeah, 3 and 9.
9 and 3, and then 3 and 7, and then 5 and 7. So 7 appeared as a first projection here. This is 3, 9, 3, 5. No. So there are two reasons. The first one, 3 appears twice and 7 didn't appear at all. So that's why it's not a function. Okay? Only one reason makes it not a function, like 3 appeared twice. Okay, if 3 is not appeared as twice, okay, also it will be not function. Why? Because 7 didn't share in the participate, okay, at all. Okay, because 7 didn't participate in the relation at all. Now it's clear?
It's clear, yeah.
Okay, great. So if it's not a function, so this means that there is no range. We can't say that find the range. Range only on the function. Okay?
Okay.
Okay. The next one, it will be like this. 3, 5, 9, 7, the same. 3, then 5, then 9, then 7 here. Okay, what about the arrows? One arrow from 3 to 5, one arrow from 5 to 3, then one arrow from 9 to 3, one arrow from 7 to 9, and one loop here on 7. Okay, so now this one is a function or not?
Not function.
Why not function?
Because the 7 is twice.
Very
Repeat
good.
twice.
Yes, exactly, because 7 here, now 7 and 7, and here 7 and 9. So 7 participated twice or appeared twice as a first projection. Okay? That's
Okay.
why it's not a function. Very good. Then the next question will be about the Cartesian, okay, diagram. Let's check it. If there is a Cartesian diagram like this one is 4x and this one is 4y. So this one is x and this one is y. What are the elements here? It's given that x equals the set of 0, 1, 2, 3, 0, 1, 2, 3, and the set of y equals 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Okay, so place the elements of 0, 1, 2, 3, and here 5, 6, 7, 8, 9. Now draw the perpendicular net. Okay, horizontal lines from y like this, and then vertical lines from x like this. Okay, then this Cartesian diagram is given like this, and there are some points placed here. So here 1 point, and here also 1 point, and here 1 point. Where is it exactly? Here. Okay, and one more point here, and one more point here. So if I want to know if this one is function or not, can you tell me exactly this one is a function or not and why?
Yeah, this the dot function
Yes, great. It's not function. Why?
because the line of 2 is repeated twice
Very
in
good.
the
Very good. Because the vertical line which passes through the element, okay, 2 has 2 points. Okay? Because this
okay.
line has 2 points. Vertical line. This one I mean. This vertical line has 2 points. So in this case, it's not a function. Great. Then the next one, let's just clear the points. Okay. The next one will be like this. 1 point is here. And 1 point here. And 1 point here. And 1 point here. So in this case, this one is a function or not? And why?
This a function
Great. Actually, this one is a function. Why? Because each
because
vertical line has only 1 point. So this vertical line has only 1 point. This vertical line, one only point. Here also only 1 point. And here also only 1 point. So this means all elements participated once, right? So
nice.
exactly, this is a function. Okay, very good. So this one is a function. Can we get the range? Of course we can. How? We said that the range is the images, okay, on Y. So this element, first element, which is 1 or first 0, sorry, 0 has an image here on Y on 9, right?
9, yeah.
Next element 1 has image here 6. Again 2 the same number 6. 3 the same number 9. Okay, but we said that we will not repeat elements, so range will equal only 6 and 9. It's 6 and 9 and 6 and 9, but we will not repeat elements. Okay?
Okay.
Now, is it clear?
Yeah, it's clear.
Okay, very good. Then one more example on the same diagram. Let's remove these points at all and place new points. If it's like this, 1 point here, 1 point here, 1 point here. So this one is a function or not?
It's a function.
Why function? Check it again. Do all elements shared on the relation?
No, it's not function because there's 7.
Okay, where is that point on this line? Do we have here any point on this vertical
No.
line? No. So this means 2 didn't share on the relation. So this means it's not a function. So now this one is not a function. Okay. One more example like this. If the points are like this, so this one is a function or not?
It's not function.
Why not function? Do we have more than 1 point on the vertical line?
No, but it's in the another line.
I don't care about the y. I don't care about y. All what I care about is x. Now, all elements on x shared and have 1 point or not?
Yes, sure.
So this means it's a function. In this case, what will be the range? It will be 5 only.
5.
Okay?
Okay.
Okay, great. Now this point is clear?
Yes, clear.
Okay, great. Let's solve one more example. Okay, fx equals the set of 0 and 1 and 2 and 3. And y equals the set of 2 and 3 and 4 and 5 and 6. Okay. Here the relation from x to y. Okay. And a relation b means a plus b equals 5. Okay. Now state the relation and mention if it's a function or not. And if it's a function, find the range. Okay, it's very easy. How to state the relation? Relation will equal the set of. We said that a plus b equal 5, right?
Yeah, right. Equal 0
First,
plus 5.
a
0,
and
0
b.
and 5.
0 and 5. Great. So first will be 0 and 5. Then
1 and
1
4.
and
And
4.
4.
Great. 1 and 4. Then
And 2 and 3.
2 and 3. Very good.
And 3 and 2.
And 3 and 2. Great. That's it. So this is the relation. Okay, so this one is a function or not?
This?
Of course. What are the elements of x? It's 0 and 1 and 2 and 3. So on the ordered pairs, 0, 1, 2, 3.
3.
All elements are appeared on the relation or as a first projection for one time. So this one, of course, it's a function. So now it's a function. Find the range. The range will equal, we said that the second projection. So 5
and 4 and
4.
3 and 2.
Great. 5 and 4 and 3 and 2. Okay, very good. Okay, let's check one more question. Okay, now if x equals the set of 3 and 2 and 1 and 0 and 1 over 2 and 1 over 3. Okay, the relation is only on x. So now here, relation on x. So this means we don't have any more sets, only x. Okay, and the relation here, a relation b, means a is multiplicative inverse multiplicative inverse of b. State the relation and if mention if it's a function or not, and if it's a function, find the range, okay, as usual. But first, what's the meaning of multiplication inverse or multiplicative inverse? Okay, multiplicative inverse means I will just flip the number, okay? So this means the numerator will becomes a denominator and the denominator will becomes numerator. Like what, mister? Like 2/3. So the multiplication inverse here will be 3/2. I'm only flipping the number. Okay, if it's a negative 3/5, this means also negative because I will just flip the number. I don't care about the sign with the same sign. So negative 5/3. If it's a whole number like 2, okay, so simply 2 means 2/1, right?
One
So
over
1
one
over
over
2.
two.
Great. Okay, so if it's 0, no, because 0 is 0/1. We don't have 1/0 because 1/0, it's not identified. Okay, it's
It's
not
one.
defined at all. So 0 has, sorry, 0 has no multiplicative inverse. Okay.
Okay.
Okay, then one more small question. What will be the multiplicative inverse of 1, for example? Actually, 1 means 1/1, right?
Yeah, one
So
over one.
1/1. So the multiplication inverse for this one also 1? Yes. So the multiplication inverse of 1 is 1. What about -1? It will be the same. Also, the multiplication inverse is -1. Are we clear?
Yeah, it's clear.
Okay, very good. Then let's solve, okay, our question now. Now the relation here will equal. We said that A is a multiplicative inverse of B. Okay, so this means first element 3 is the multiplicative inverse of B. So 3 is a multiplicative inverse of 1/3.
Of 1/3.
So 3 and 1/3. Then 2 and
Two and
1.
1/2.
Great. And then 1.
1/1.
Yes, which is
One and
1.
one.
Yes, exactly. Great. 0. Do we have a multiplicative inverse for
No,
0? No.
yes, no.
Then what about
No.
half?
1
1
half,
over 2
two.
and 2.
Two.
Great. What about 1/3? 1/3
Three.
and 3. Great. Okay, in this case, this one is a function or not, we have to check the x elements. 3, 2, 1, 0, half, third. Okay, so 3, 2, 1, half, and 1/3. Okay, then what about 0? 0 didn't share. Oh, yeah, so this means not a function, right? Because one of the
Right.
elements didn't appear on the ordered pairs as a first projection. Okay, so this means this one is not a function. Okay, are we clear?
Yeah, it's clear.
Okay, very good. Very good. So do you have any questions till now?
No.
Okay, great.